My name is Thomas Sierra. I'm here from Coral Glades High School, and I'm here to explain to you an everyday phenomenon called the Doppler Effect. Now, you very often see this with car sirens, police sirens, ambulances across streets, and the main part that I'm going to explain to you today is how the physical phenomena of this translates from the real world to the mathematics behind it. So normally, when you have a frequency coming from a fixed source of sound here, the wavelength stays constant around the sphere. But as the sphere starts moving towards you with a set velocity, the wavelengths actually compress and get smaller, which causes the observed frequency and pitch that you perceive to be much higher and increase. Now this is just an example where we had a first initial fixed sound of 600 hertz, but then here, because of the Doppler effect, it went up to 660 hertz. And that's mainly because of this formula here, this relation, whereas you have the constant velocity of sound, and then as this wavelength decreases, your perceived frequency was actually going to increase. Now, in the other case, the opposite is true when you're away from the sound, as in this man right here, who, because it's compressing over on this side, the wavelength is actually going to increase and decompress on this side, causing his perceived frequency to actually be much lower, to be 560 hertz, which means it would sound like a deeper tone, while his would sound like a higher tone than what is actually being displayed. Okay, now I'm going to show you a fun way to see the Doppler effect in action using your computer. You can go to this website right here on the top, and we'll see this by seeing increasing the frequency, which would be when an object comes towards you, and then decreasing the frequency as the object moves away. So first, this is our standard frequency that we're going to observe, and then as the object would move towards you, you would hear an increase in frequency, like this, and then as it moves away, you would hear a major decrease like this. There you go. So now we transition from the laptop to the actual cell phone, which you can put the same website on your phone, and actually I'm going to show you a really fun way how to see the Doppler effect by using a plastic bag and a string. Doppler's findings can also be thanked as a component of modern ultrasound scans, using variation in observed frequency from movement and proximity to generate an unintrusive view into the human body. This has without a doubt saved the lives of countless patients, as well as allowed for babies who would have suffered birth complications to be delivered more safely. Finally, the Doppler effect has increased forewarning of major storms, like destructive hurricanes, through mapping the different frequencies observed from approaching weather systems, as well as being a chief reason for the absolutely awe-inspiring effect of jets breaking the sound barrier, which fly fast enough to literally compress the air and sound waves in front of them to the point of snapping. How much cooler can the Doppler effect get?